like sunshine, like springtime, like something's in the water and I'm taking a deep dive. I'm feeling so weightless, like I'm gonna make it, and nothing in the universe can take this. I can see it clearly now, nothing gonna bring me down. I got my head held high, I'm on my way, and I'm following the signs to my happy place. I'm walking in the light of a brand new day, and I'm right where I belong, in my happy place. I got my head held high, I'm on my way, and I'm following the signs to my happy place. I'm walking in the light of a brand new day, and I'm right where I belong, in my happy place. And I'm right where I belong, in my happy place. And I'm right where I belong, in my happy place.
Thank you, and welcome to our third in this series on healthy longevity. And this is an exciting night because we have with us Dr. Aubrey de Grey, who's going to be determining whether damage repair can give us indefinite youth, something we really want to know about. And it'll be an exciting conversation. I would remind you to use the Q&A function to ask questions, and we'll try to get to as many of those as possible. Before we go to Aubrey, we're going to continue with our approach of hearing what Singaporeans think about aging. And tonight we're going to hear Mr. K. Kazavapani, tell you his thoughts.
Hi, my name is Daniel C., a Year 1 medical student, and welcome back to the Healthy Longevity webinar series. Each week, we hear from fellow Singaporeans about their ideas on healthy aging. This week, let's hear from Mr. K. Kazavapani, who is currently the president of the Singapore Indian Association. Mr. Kazavapani was also the director of the Institute of Southeast Asian Studies from 2002 to 2012. He was also Singapore's High Commissioner to Malaysia from 1997 to 2002 and one of the founding executive committee members of the Dyslexia Association of Singapore. Mr. Kazavapani is 84 this year, and he still finds the time to immerse himself in community service and helping various charities. He is a firm believer of walking, writing, and not worrying too much when it comes to helping one stay active and healthy. He shares more with NUS medicine student Jonathan Tan about what he thinks on healthy living.
What is your take on healthy aging?
Healthy living or healthy aging consists of 4 parts in my case. 1, a healthy body. 2, a healthy mind. 3, a healthy family. And 4, some very good healthy friends. Healthy body means you have to take care of your body. You cannot neglect your body. You cannot abuse your body. And thankfully in Singapore we have a very good health system, and you are taken well care of. Second thing is a healthy mind, because the body consists of mind and matter, is it? So for a healthy mind, you have to keep yourself active mentally. You have to make sure that you just don't lose out on your reading, on your writing, on your skills, and also thought process. If you are positive in your thoughts, your body also will be positive. If you are negative in your thoughts, then the consequences are you will fall into depression, you will fall into dementia and all kinds of things. So I am by nature a very positive person. I look at life and say, I'm a great believer in what the Persian poet said, Omar Khayyam said, the moving finger writes and having great moves on. Now all thy tears, now all thy piety can mirror it back to cancel half a line. So it's already there. So why worry? Worry is the biggest. Why worry until worry worries you? You know. So you have got to equip yourself with these kind of positive sayings, quotations. Read books by people who have good experiences, and so that's how I keep my mind alert. Family, of course, is a very important. If you're lucky, you get everybody in the family happy, but you can't wish that. You know, that's false. But even then, you can be positive and wait for better things to come. So family is important. Most important, I think for me, is also friends. Friends are very important because you're a social animal. A man or woman is a social animal. You cannot go into seclusion or reclusion until you want to be a Buddhist monk or something like that. So you have to have a select group of friends, not too many, but a select group of friends with whom you interact, you enjoy. Like I have a group on Sunday. Feel good. Feeling good is very, very important. If you don't feel good about yourself, nobody is going to feel good about you.
So, what do you do to stay healthy these days?
I walk. I'm a great believer in walking. So almost every day or every other day, unless you become lazy, I take a walk. I mean, it's just this lovely neighborhood. Walk for 3 minutes, 3 kilometers, 4 kilometers, and then come back. So walking is cost-free, because unlike other games, it's a cost-free exercise, you know. And once in a way you go to botanical gardens, and Singapore has some lovely places to go, and every day you can choose, you know. You can do it either singly or you can go with groups. I keep my days free.
And you know, how do you keep active and positive, especially in this COVID season?
Going and helping in also raising funds, or generally, you know, whatever comes that day. And believe me, there's not been a single day when I've got up and said, what am I going to do today? Because there's a lot of things to do.
And finally, as we wrap up, do you have any tips for our seniors to age healthily in the community?
Read the book which you have never read. You know, write something that you have never written, and you know, it's within you. It's within you. And a lot of my friends have told me this is the first time that you have not been rushing around, not been rushing as though the world will collapse if you don't get this done. You just stay at home. The world will go by its own. COVID will take its course, but you can do what you want, and that's very, very important. But aging is a number. Age is a number. Age is not a. It's not that if you reach 75, so you're going to go this way. If you reach 80, you're going to. Age is a number. So, what is of concern is that you do not neglect your body. Don't stop thinking. Don't stop. Don't worry. Don't worry too much. And be positive. Be positive. And always have something to do. Something to do. And that will keep you. For example, I wrote this book, you know, when I was 82. It's a story of my life. And I found that, you know, a lot of people were sort of said, hey, I also have similar experiences. So write something. Writing is a very therapeutic exercise.
So it's a great pleasure to have Aubrey here tonight. I think most of you probably know who he is. For those few of you who don't, he's the Chief Scientific Officer of the SENS Foundation, and has been, which has been long devoted nonprofit organization to funding aging research, and they specialize in funding projects that other people might not fund. So ideas that may be a little more visionary that might lead to big impact in the long term. He's also the editor-in-chief of Rejuvenation Research. And I think what excites me most about having you here tonight, Aubrey, is that this is the third part of our first month of the series. And we had Matt Kaberlein in the first show to tell us sort of about the basics of aging. And then Paul Irving to tell us about population aging. And we're relying on you to tell us about the future. Where's the longevity research going and what's your current vision? So with that, I'll turn it over to you, and I'm excited to hear your talk.
Well, thank you very much, Brian. It's great to be here. And I'll just share my screen and take it from there. So yes, hello everybody. I'm delighted to be here. I see that there's quite a substantial audience, so it's always great to speak to a new group. I've had the great pleasure to come to Singapore a few times over the past few years, but not for a little while, so it's great. And I think I'm going to start by talking a little bit about terminology, about the word longevity. We use the word longevity a lot in this field, especially when speaking to the wider world, the general public. And it's a little bit dangerous to use that word because people often make their own story around what this research is really for. So this is what I really want to start with. The reason I make this point is because when you talk about longevity, even if you talk about healthy longevity, a lot of people hear the concept of getting people to live a long time in a state of health that is characteristic of today's elderly people. And even people who might say that they are healthy for their age, they're definitely not really healthy. They're not able to, keep up with their granddaughters on the dance floor. So I think it's very important to emphasize right at the outset that what people like Brian and Matt and myself work on is actually health. We do medical research, that's all. And yes, the medical research that we do has the potential to deliver a big side effect in the sense of allowing people to live a long time, simply because what we do has the potential to prevent all of the aspects of ill health that currently have so much impact on the health of the elderly. And therefore, as a side effect, will help people to live longer on average, simply because these days, most people die from being sick. But it's still just a side effect. So I really want to emphasize that at the beginning. Now, the real reason I want to do that, and this may well have come up a week ago with Paul Irving's talk, is that a lot of people, when they hear about longevity research, they fixate on the side effects, on the longevity side of things. And they kind of forget that this is all about something that they definitely want, namely to avoid getting sick as they get older. They think about things that might happen if everybody lives a lot longer, a lot longer, and they think, oh dear, wouldn't there be other problems that would come along as a consequence of solving the problem that we have today? They would say to themselves, or they will say to each other, oh dear, well, we put all the people, or they'll say, won't dictators live forever, or won't it be boring, or doesn't death give meaning to life? Things like that. And, those of us like Brian and myself who do a lot of public speaking and interaction with the general public, we have to spend most of our time contending with this problem, these potential concerns that people have. So I like to go in at the beginning and emphasize that these concerns are misplaced, because we are talking about medical care here to keep people in a better state, both physically and mentally, than they could otherwise hope to be in at that chronological age. And yes, we may face new challenges. There are, in fact, very straightforward solutions to all of the problems I've listed on the left of this slide, and indeed many other problems. But even if there were not, we still have to have a sense of proportion about this. We have to remember how important it is to people to stay healthy. So now I'm going to move on to the science of what SENS Research Foundation does, and indeed what all people who work on the biology of aging really do. What we do is we're interested in keeping people healthy. And the first question that we therefore have to ask ourselves is, why hasn't this already been done? Because we have had, as a society globally, enormous success over the past, let's say, 200 years in preventing the health problems of early life. Even in the wealthiest countries in the world 200 years ago, more than 1/3 of babies would die before the age of 1. And of course, many people would die in childbirth and throughout the life cycle. And the way that we stop that, the reason why today hardly anybody dies early in life, at least in the industrialized world, is as a result of really simple measures. Just figuring out that hygiene is a good idea was insanely useful. It saved the most unbelievable number of lives. And really simple medicines like vaccines and antibiotics have more or less eliminated the diseases that killed most of these babies in infancy, things like diphtheria and tuberculosis. So the first question we have to ask ourselves is, what is so different about the diseases of old age that has prevented medical research from bringing them under control to the same degree that we have achieved with most, albeit, as we very well know, not all, infectious diseases? Most people think that this is the answer. And don't worry, you're not supposed to be able to read this slide. The point I'm making here is simply that an awful lot of things go wrong with us late in life. And they go wrong at more or less the same time, which means that they interact with each other, they exacerbate each other. So, most people think, well, that's all it is, really. It's just the complexity that has overwhelmed the ability of medical research to bring this under control. And yes, that is part of the answer, but it's only part. And I want to, first of all, now address what is the main reason why we haven't made much progress. In order to do that, I have to start by giving a definition of aging. And if you're watching all of the talks in this series, you will probably notice that different researchers have different definitions of aging. But actually, they're not very different in the sense that we would not disagree with each other's preferred definition. So this definition that I'm using, I like it because of a couple of things. First of all, it is mechanistic. It gives you a sense of the sequence of events of how aging happens. And secondly, I think that this is a way of demystifying aging, of helping you to understand that we actually do not view aging as a particularly, enigmatic process. We really do understand what it is, basically. So what I'm saying here is that aging is the combination of two processes. One process that goes on throughout life, and I really mean throughout life, even starting before we're born, and another one that starts late in life. So the one on the left, the lifelong process, is a process whereby metabolism, in other words, the entire network of processes that keep us alive from one day to the next, generates damage. What do I mean by damage? I mean simply changes to the molecular and cellular structure and composition of the body. These changes are side effects of the way that the body works to keep us alive. And they are absolutely intrinsic. They are just going to happen as consequences of metabolism. But the body is set up to tolerate quite a lot of those changes, which is why nothing much goes wrong with us until middle age or later. A 40 or 50-year-old person is more or less as functional in both physical terms and mental terms as a 20-year-old. But the body is only set up to tolerate a certain amount of those changes. And that's why it's appropriate to use the word damage to denote those changes. Because eventually, there's more than that. We get over that threshold level of damage, and that's when the right-hand process kicks off. And that is the process whereby the health problems of late life, the pathologies of aging, start to emerge and to progress. They are driven by the presence of enough damage in the body that we simply cannot actually keep it going. So this is what aging is. It's simply the combination of these two processes. So what does this mean? Well, the reason why I have been so careful to give you this definition of aging is because when you don't have a good definition to start from, you tend to make mistakes about what to do about it. And here's the first mistake that almost everybody makes. If you ask somebody, in what ways can people get sick? Then the answer that they give will almost always be something like what you're seeing on this table here. First of all, they will say, well, okay, there are infectious diseases. That's column 1. Then there's genetic diseases that a few of us are unlucky enough to inherit. That's column 2. Then there's the big one, the chronic progressive diseases of late life, such as Alzheimer's, almost all cancers, atherosclerosis, all of the things that I put up in that really small font earlier on. And then most people would say that way out in the stratosphere, there's this fourth category of ways to be sick, which is called aging itself. And it consists of these rather poorly defined concepts like frailty. And the inherent, intuition that people have about aging itself is that it's completely different from diseases. In fact, so different that people think of it as kind of off limits to medicine, even in principle, right? That it's kind of woven into the fabric of the universe and it's just not like diseases. And that's a big problem because what it leads to is a very unproductive approach to treating the things in column 3. Those things like Alzheimer's, the diseases of old age. What we do today, almost all of the money that is spent on medical care for the elderly comes under the heading of what I'm going to call geriatrics, geriatric medicine. And that consists of directly attacking the pathologies of late life, rather if they were infections, trying to eliminate them from the body. What that means is, it's bound not to work, because just looking back at this really simple picture that I showed you a moment ago, you can see that what that amounts to is attacking the consequences of something that's accumulating, this thing called damage, which means that kind of by definition, geriatric medicine is certain to become progressively less effective as the person gets older. It's just never going to work. So you may think, well, hang on, why, if this is so obvious, then why are people still trying to do this? Why is that still the main paradigm in keeping people healthy late in life? Is the answer that there's no alternative? Well, as you're about to see, no, that's not the answer. The answer, I believe, is simply because people are not thinking correctly about aging. This is the way that we should actually be thinking about the answer to this question, how can people be sick? If you look closely, you will see that all the columns are the same as they were in the previous version of this table. The only difference is that I have shifted that big black line. What I'm emphasizing here is 2 things. First thing is that column 3 is nothing like column 1, that there is absolutely no reason to suppose that the things in column 3, the health problems of late life, should be amenable to the same kinds of medicine that have worked so well against most infectious diseases. But the other really big thing that moving the black line emphasizes is that there is basically no difference between column 3 and column 4. Really, the only difference is semantic. Things in column 3 are just the aspects of aging that we have chosen to give disease-like names to, and that is all. Which means, of course, that column 4 is definitely not off limits to medicine, because for sure column 3 isn't. So that's a very important thing to take into account. But what does it lead to in terms of options for intervention? Well, it does have some consequences. More than a century ago, a few people started to realize what I've told you so far, that geriatric medicine is basically never going to work. And they said, well, okay, we've got to be more preventative. And the whole field of gerontology emerged. It was really inspired by the living world, by the fact that when we look at nature, we see a great variation in the rates of aging. Some species age much faster than others. And so the idea was, well, maybe if we study this really hard, we will understand it well enough that we'll be able to translate that understanding into some kind of therapy to, if you like, make the body run more cleanly, so as to slow down the rate at which metabolism generates damage, and thereby, of course, postpone the point at which that damage reaches the threshold level of abundance that causes the right-hand process to kick off. But unfortunately, that also has pretty much completely failed to postpone the health problems of late life. Why is that? Well, here it really is just complexity. The fact is that metabolism is viciously complicated. What I'm showing you here is a simplified diagram, believe it or not, of a small subset of what we know about how metabolism actually works. And as you can see, it's really nasty. Anyone who's listening who has ever written software, you will immediately see that this is the ultimate nightmare of uncommented spaghetti code. There's just no way we're going to be able to unpick this and stop metabolism from doing the thing we don't want it to do, the creation of damage, without at the same time having unintended consequences that stop it from doing things we need it to do to keep us alive. But luckily, there's a third approach. And I'm going to call it the maintenance approach. We call it the damage repair approach. What we are trying to achieve here, if we come back and remember that, is we're trying to separate metabolism from pathology. We want people to carry on being able to perform metabolism, in other words, be alive, without having them go downhill and become sick. And so separating metabolism from pathology could, in principle, be done in several different ways. I've shown you that we're not going to do it by separating damage from pathology, and we're also not going to do it by separating metabolism from damage. But we could instead go in and periodically repair damage that had already been created. And in that way, we would be able to stop the right-hand process from happening. We would stop the damage from reaching the pathogenic level of abundance without necessarily having to slow down the rate at which damage was being created in the first place. And really, this looks quite promising. I think it may look a little bit arrogant to call it the common sense alternative, and this essentially to say that the other approaches don't make sense. But I don't think it's an exaggeration. The reason I don't is because we already do it successfully, and we've been doing it for a long time. So what I'm showing you here is a car that is more than 100 years old. So why is it working still? It's not because it was designed to last 100 years. This car was probably designed to last 10 years, but it has benefited from comprehensive, periodic, preventative maintenance throughout its existence. And sure enough, it's working just as well as when it was built. So preventative maintenance just works. The human body is, after all, a machine, so we ought to be able to do the same thing. Putting it another way, we could say that aging is a phenomenon of physics, not biology. Consciousness is a phenomenon of biology. Cars don't have it. But aging is really just the same thing in the human body as it is in a simple man-made machine. And comprehensive preventative maintenance, therefore, ought to work. So there's just one thing I haven't really addressed yet, which is, can we actually do it in practice? Because let's face it, if metabolism is so complicated and pathology is also so complicated in aging, then maybe we should expect that the damage that lies in the middle between the two is also really, really, really complicated, which would mean that even if this is the common sense approach, it's still not practical. But luckily, it seems that that's not really the case, because we can actually describe what the damage is. On the left-hand side of this table, I am listing 7 categories of damage, things that go wrong with the body late in life, changes to the molecular and cellular structure, as I said earlier, that eventually become too abundant for the body to cope. And this classification is quite manageable, just 7 categories. The utility of that classification is the right-hand side of this table. The fact that for each of these categories, we can describe a generic approach to actually fixing it that will, in fact, allow us to implement the maintenance approach. And these generic therapies are generic in the sense that for each example within a category, there are differences in detail, but only in detail. So for illustration, let me just talk about the first category, cell loss. What I'm talking about here is simply when cells die and they are not automatically replaced by the division of other cells. When this happens, of course, the number of cells in the affected organ will decline, and eventually there will not be enough cells for the organ to do its job. We can fix that in principle using stem cells. We prepare cells in the laboratory so that when we inject them, they know what to do to divide and transform to replace the cells that the body is not replacing on its own. And of course, different stem cell therapies for different tissues have differences, but they also have a lot in common. So once you've got a couple of stem cell therapies working well for different tissues, getting the next one working is going to be a lot faster and easier. That's why it's really important to have this classification. So yes, absolutely, damage is complicated, but it's not unmanageably complicated. And if I just briefly talk about what SENS Research Foundation does, we have been pursuing this damage repair approach for many years now, and I'm very proud to say that we have succeeded in really initiating and kickstarting a number of very important areas of biomedical research that had previously been neglected or considered to be just too difficult. I'm just picking out a small selection of the papers that we've published over the past many years. I chose these ones because they were particularly breakthrough papers that really made a complete difference to how we were able to study and intervene in certain aspects of aging. And many of these research fields have now moved into the private sector and are being pursued by startup companies. Furthermore, in the academic field, this whole idea of a kind of divide and conquer damage repair approach to addressing aging has become very mainstream. When I first started talking about it 20 years ago, it was quite controversial. And a lot of people didn't really understand how it could work because it did involve bringing in a lot of science that had previously been developed outside of gerontology. And people who studied the biology of aging really didn't know much about it. But now, in the past decade, that's completely changed. I'm just showing here for illustration a paper that came out 7 years ago, and it was by far the most highly cited paper in the whole of the biology of aging in the past decade. And as you can see, it's very much the same idea. They split aging into 9 categories instead of 7, but that's just a different way of doing the subdividing. It's not coming up with anything that I hadn't said 10 years earlier. And you see the right-hand side is the corresponding intervention. So this is an idea that's now completely mainstream and orthodox. I mentioned earlier that a number of these areas have now moved into the private sector, and I would say that that's the biggest thing that's happened over the past few years, the emergence of an increasing number of courageous but very rational investors who are willing to come in and actually support projects in this early stage before they've reached the clinic and take them forward all the way to the clinic. This is very important, largely because investors write bigger checks than donors do. So these projects are now being supported by much better financial support than they had before. And that's extremely important. It's unevenly distributed, I have to say. The reason why SENS Research Foundation still exists is because there are still some really vital projects that have not yet reached a sufficient level of proof of concept to be able to be spun out in this way, but it's still happening. And it's very much not only spin-outs from SENS Research Foundation that are involved in this. I'm listing here a ridiculously incomplete number of companies that have emerged aligned with this idea, doing damage repair in one or another way. if you're interested in exploring this more, I recommend the website that I've listed at the bottom right of this slide, and which is the best that exists right now in terms of a comprehensive database of such companies. But even that, it's extremely hard to keep up to date because this field is exploding exponentially right now. So I'll stop there. I'll just mention that many years ago, I wrote a book on all of this. The book is 13 years old now, so you may wonder why I even recommend it. And the answer is because it's still quite up to date. Not because of lack of progress by any means. There has been massive and massive progress, as I said earlier, but rather because the progress has been very much what we predicted it would be. And that's important to remember because it shows that this whole damage repair idea is standing the test of time. It shows that we really do understand aging pretty well at this point, well enough that we are entitled to be optimistic about the rate of progress over the coming decade. So I'll stop there. Thank you very much.
Thank you, Aubrey. That's really interesting. I think it's exciting always to hear your talks. And, you know, we've had a number of really exciting conversations over the years in various parts of the world. And I've always thought those have been very informative and also very interesting. But I have to let you know that I think all of them have been alcohol assisted. And so this may be the first time we're not using alcohol. And I don't know how that's going to turn out. So I've got my fingers crossed.
Yeah, well, I've got coffee and you haven't. So.
Let's start with one of your comments about the difference between metabolism and damage repair. I think that somebody that might say, well, look, all the interventions that are known to affect aging could be called metabolic interventions. Rapamycin, the TOR pathway, metformin, regulating glucose control. Now, I know the downstream of that is repair of protein damage and things like that. But how much of a difference is there in terms of modifying metabolism versus repairing damage? Or are you thinking that those are small changes and what we really need to do is focus more directly on the damage repair?
You've pretty much said it, Brian, there. I think that a lot of the people who work on the biology of aging over the past century have been a little bit misled by the extraordinarily promising phenomenon that was discovered in the 1930s, whereby if you take a laboratory organism, initially the focus was on rodents, on mice and rats, if you feed such an organism less than it would like, then it lives longer. And the numbers are quite impressive. If you feed a mouse maybe 30 or 40% less than it would like, then it lives 30 or 40% longer than it otherwise would. If we could do that in humans, then that would be a really big deal. And indeed, even when I got into the field in the late 90s and the early 2000s, very well-respected and knowledgeable people were feeling able to say that that was the goal, to try to get the same proportional increase in longevity in humans. But it always seemed to me that this was somehow mistaken, because there was already, by 20 years ago, very clearly a strong inverse correlation between the amount of life extension that you could get by this means versus the longevity of the species in question. So very short-lived species that live only a few weeks, you could get them to live maybe 5 times longer than normal by this kind of approach. Whereas the longest lived species that had been looked at back then was Labradors that live about 11 years, and you could get maybe 10%. At that time, there was an ongoing experiment or two going on with non-human primates. And eventually, when that experiment concluded, it was even less than that. It was a couple of percent if you were lucky. So, and furthermore, this made evolutionary sense as well. So now I think people generally accept that you're not going to really get much in the in terms of longevity from humans who are very long-lived by this kind of approach. And of course, drugs like rapamycin and metformin and resveratrol have tended to be ones that try to trick the body into thinking it's on this famine diet, this starvation diet, when it's actually not, because of course that's rather important, because humans like to eat. Now, I'm not saying, therefore, that these interventions are in any way worthless, not at all, because for sure they keep people healthier longer than before. But they're definitely not the Holy Grail. And I think that if we have more focus, as we are having these days, on damage repair, then we're likely to see considerably larger postponement of the health problems of late life than what we're going to see if we focus on making metabolism run more cleanly.
And that brings up an interesting point, because I think all of us are kind of struggling right now in terms of how do we do clinical trials and validate that we can alter the rate of aging. And there's been sort of the approach of targeting longevity pathways and then trying to treat disease. There's been trying to do things like the TAME trial, which is to prevent multiple diseases simultaneously, and more recently studies with biomarkers. Where do you weigh in on those options?
So yes, it's of course extremely inconvenient that aging happens so slowly, because it means that the endpoint that we're looking for, namely people getting sick, is something that it's some way in the future. Indeed, this is a real problem for preventative medicine in general. Preventative medicine is the exception rather than the rule these days. We have a few examples of very successful drug families, like statins, for example, that are used by people who are not yet sick, because it is generally understood that they will postpone the time when you do get sick. But it's really the exception. And I think part of this is societal and, just people don't really understand it very well. They know kind of medicine is a bit black magic, and that experimental new drugs might do more harm than good, especially if you're not yet sick. So preventative medicine is a hard sell in the first place. But in the case of aging, it's a long time in the future that you might expect to get sick. And so getting people to really pay attention to this is harder. And this is another advantage that damage repair has relative to cleaning up metabolism. If you're cleaning up metabolism, you'd better start early, because if you have already got most of the damage that you need to have to get sick, then halving the rate at which you make more damage is only going to give you a little bit of benefit. Whereas with damage repair, you can start in middle age or later, and you can expect to see a big benefit.
Yeah, I want to come back to these 7 strategies you proposed. I guess it was 20 years ago now, probably they started. Which ones have we made the most progress on? I think you would argue in your talk that you'd stick with those 7. Or which ones are proving difficult? Which ones are proving relatively easier?
Yeah, so the ranking in terms of difficulty has stayed pretty much the same over the years. When I first started talking about this and thinking about it, it was already the case that stem cell therapy was a respected concept. People knew that it was a good way to restore the number of cells in a tissue. All of the other 6 were really way down in terms of people's appreciation of the idea that they could even be possible, even in theory. And all of them have made progress. I would say that what SENS Research Foundation has done has tended to be focusing on the most neglected, which generally means the most difficult ones. And even as little as 3 or 4 years ago, I could not put my hand on my heart and say that we had made substantial progress in all of them. But I can now, even on the most difficult ones. So they're still the most difficult. They're still like lagging behind and they need to catch up. For example, mitochondrial mutations is one of the 7, and dealing with them is a really challenging thing to do. It's not yet been spun out as a startup company. It will be, though. We're probably only, I would say, 5 years away from clinical trials for ways to restore the function of mitochondria that have accumulated mutations. So yeah, I would say progress is very encouraging.
That's great. I think that both of us have been trying for a long time to convince people that more resources need to be poured into longevity research. And I think that recently there's been a big movement from the private sector, which is, and certainly in part due to your efforts, so that's a good sign. But how much progress are we making? Or you feel like the public is really starting to change their opinion? Do we still need to go to governments? Can we just do things through the private sector and have success that way? What's the next step in terms of changing this paradigm?
Yeah, I mean, I've come to the view over the years that there is no one next step, that we have to kind of advocate in all communities, whether it's the general public, whether it's investors, whether it's the government, and generally just build things up brick by brick and do what we can in the laboratory to make incremental progress that allows us to make stronger and stronger case that this really is possible and that, this is not just science fiction. But yeah, how to do it more? Well, actually, let me talk about COVID for a second on that, because I think COVID may have a silver lining, maybe a bit of an opportunity here. The thing we are seeing worldwide with relation to the pandemic is that the general public have almost all been willing to submit to the most extraordinarily onerous restrictions on their lives, even though most people are not at risk to speak of. This is an extremely age-specific disease. Even by the standards of most infections, the elderly are far more affected. Young adults, really, unless you're already exhibiting some of the conditions of late life prematurely, you're generally going to be pretty safe. And yet, people are willing not to go to work and so on. Now, this tells me that the elderly matter to youngsters. In other words, there are votes in actually putting serious taxpayers' money into hastening research to keep people healthy late in life, including, of course, keeping people's immune systems healthy late in life. If that can get through to policymakers and decision makers, especially elected ones around the world, then we could be in a very different world.
I hope so. And, also a successful vaccine development will hopefully reinforce people's confidence that science can do good for them too. So I'm hoping that's a positive thing. Why don't we go to Max, who's been assembling questions from the audience, and hear some of their thoughts.
Maybe let's start out with a question from Gregory Belleau, who wants to know, how would you assess and define the threshold of damage that necessitates a damage repair?
So this is really a question about measurement. And one of the most difficult things in studying aging is that the underlying primary molecular and cellular changes that occur that drive eventual sickness late in life are often very hard to measure directly. So we have to kind of measure proxies of them. But that's okay, because a lot of the research that people like Brian and myself do is precisely to develop good proxies that actually work. One really big area that I haven't mentioned yet of gerontology research right now is the development of biological clocks, which allow us to predict reasonably accurately how soon somebody is going to start exhibiting the chronic progressive conditions of late life as a result of some molecular signature that they already have. This is something that people have hoped for decades and had very little success, but it has benefited over the past few years from the emergence of very high throughput technology that can, for example, measure aspects of the entire genome or the entire proteome very quickly. And we're now getting pretty close to having quite reliable predictors of that nature.
It's also a great application of artificial intelligence, I think, that in the aging field.
Yes, certainly.
Maybe like another question from Edosi Okpara, and he wants to know, are there any molecular mechanisms basis for a role for alcohol in the aging process or accelerating aging generally? I think that fits you guys.
Well, yeah, alcohol is a bit like sex when it comes to aging. In other words, there are people who say that it's good to have less of it, and there are other people who say that it's good for you to have more of it. It probably depends. I think, they have this phrase that says, everything in moderation, including moderation. And I think that's about all we can really say about that.
They're not those two things are not entirely unrelated to each other either. So it's there's a dependency.
Yeah, I mean, one thing to really emphasize here is that the reason there is controversy on points like this is because everybody's different. There is no one size fits all when it comes to staying healthy late in life. So what we can do today in terms of lifestyle and diet and such like varies enormously from one person to another. So the only generic advice that one can give is pay attention to your body, figure out what your body doesn't like and don't do it.
Following up on a question from Craig Bachman, who wants to know, as a philanthropist or an investor, how do I identify the best places to put money in a startup or an organization?
Oh, that's very easy. You send me an email and I will tell you. Of course, we do have a nice big friendly donate button on our website, and I'm sure that other nonprofits around the world who work in this area have the same, but it's a very fast moving field. So the question is very appropriate. In order to know what to do best, both as an investor and as a philanthropist, the right thing to do is to talk to the experts. And a large part of the reason why I and Brian and a number of the other most prominent researchers in this area spend so much of our time talking to the general public is precisely because we regard it very much as part of our job to educate people who can help. And of course, this applies not only to help them financially, this applies to opinion formers, it applies to scientists for that matter, people who are thinking of going into science. Just yesterday, I was giving a talk to a bunch of undergrads who had not decided what to do with their careers, and I hope I inspired some of them to go into the biology of aging.
Yeah, I think particularly in this longevity sector that's like growing by leaps and bounds, it's kind of the Wild West right now. There's all kinds of different ideas, both in diagnostics and in treatments, or in strategies to enhance health span. And I think nobody really knows what all the right answers are, but that's part of what makes it so exciting. And of course, from a company perspective, the payout at the end of the day is quite large too. So it's really an exciting area to participate in, but maybe not the easiest place to make decisions.
Something adjacent to the aging space, Patrick Cocker has a question, and he asks, what is the role of cryopreservation?
Yeah, well, so cryopreservation is a very important and, again, very neglected area of research. And actually, one of our spin-outs here, which is led by someone who used to be our chief operating officer, is focused in this space. If you could cryopreserve solid organs like hearts, kidneys, livers, then, things would be very different in the healthcare industry. At the moment, huge numbers of people die on waiting lists, waiting for an organ transplant, simply because in order to have one that works, it needs to be compatible with your immune system. And that means you can undertake it from a very, very small number of people. And unfortunately, people don't tend to die when the recipient of such an organ wants them to, so to speak. So if we could make organ banks of organs that could stay usable for a long time, things would be very different. And there's great research going on in this space, but it's very, very underfunded. If we could actually get that to work, that would be fantastic.
Maybe if I can chime in a question by myself. Aubrey, you coming like from the approach of like engineering in a way and damage repair, and Brian is like more in the realm of like small molecules. Where do you guys disagree the most or like clash in your philosophy?
Really, I don't think we clash at all in our philosophy. I mean, even when I answered Brian's first question today on the contrast between things like rapamycin on the one hand versus proper, bona fide damage repair on the other hand, really here, there's a huge overlap in terms of what we're trying to achieve. And I certainly think that, for example, if we just look at incentives, that if people understand what's coming in damage repair and how much extra healthy life they might be able to gain, that will make them more inclined to pay more attention to their bodies, both in terms of lifestyle and diet, and also in terms of access to drugs that clean up metabolism. So there's an enormous amount of synergy between these approaches.
Yeah, I think that raises an issue. You have different damage that needs to be repaired. When you look at a lot of these interventions that currently exist, you can take calorie restriction if you want, for an example, and look at the hallmarks of aging. You can see improvements in all of the hallmarks from one intervention, or even one drug, arguably with rapamycin or metformin. So, how about when repairing damage? Are these going to be independent things, or how much crosstalk is there going to be from one form of damage to another?
Yeah, this is a great question. And indeed, I would say that I was pleasantly surprised a few years ago when we started to see the first cases of bona fide damage repair in the laboratory and its effect on aging in general. The big focus of that was one of the 7 categories I've been talking about all this time, the removal of senescent cells. This is something that we learned how to do with small molecules pretty well a few years ago. And the breadth of the benefits that were seen in the preservation of function in the animals that were receiving these therapies was much, much greater than I would have expected. So we always knew that there would be some crosstalk between these types of damage, that if you repair one of them, then that's going to make the body better at slowing down the accumulation of the others. But the magnitude of that crosstalk is a lot more than I would have expected. And of course, that is that's a hugely good surprise.
Maybe one last question. You've been attributed statements like people that are alive today are going to be alive 1,000 years from now. I don't know if you made them or not, but where do you stand on that? What's going to be maximum lifespan in the near future? Are we going up or down?
Right, yeah. So, of course, today what we're seeing is that the increase in life expectancy and average lifespan that's been going on over the past century or more is leveling off. We're seeing almost nothing in many countries right now. And we're going to need a new paradigm to change that, to allow people to live longer. Of course, as a side effect, as I mentioned at the beginning, as a side effect of living healthier for longer. How long? Well, the thing about damage repair is you can carry on doing it and you can carry on getting better at doing it. So I've put forward the concept, we may reach something called longevity escape velocity, where essentially the problem of keeping people's damage level low enough that they don't get sick becomes progressively harder over time because we can fix some of the damage and there's more difficult damage that we can't yet fix. But during that same time, the scientists are getting better at repairing damage, so we may be able to stay one step ahead of the problem indefinitely. And certainly if we did not have any case of getting sick because you're old, then people would on average already be living into their thousands. And that is actually a conservative estimate because it makes the assumption that causes of death which do not have to do with how long ago you were born will stay the same. Whereas, of course, we know that we're getting, self-driving cars and such like that are going to reduce those causes of death as well.
Oh, that's great. Maybe I just want to, before we close, I want to, first of all, thank you, Aubrey. I also want to turn to Max because Max is, as you know, if you've watched before, is a PhD student in my lab. And he's done a great job handling these questions. And so, unfortunately, this is his last show because his salary demands are just way too high for us to continue employing him. So I think what I'd like to do is ask Max to spend like 30 seconds telling us about his project.
Sure, I'm happy to. So my background is actually like in physics and artificial intelligence, and I just transitioned to like the aging field because I just think it's exciting. That's like on the border of like future and present and can see things happening in my lifetime. And I'm working on a branch of artificial intelligence called generative deep learning, and I use it for lead generation of health span prolonging molecules.
Well, thanks a lot for doing this, Max. And in the past two shows, we've left you with a video of thoughts on aging from two famous American political leaders. And I wanted to go closer to home tonight. A few years ago when I came to Singapore, one of the first questions I got asked is when Mahathir became Prime Minister of Malaysia was how in the world could a 92-year-old person be a head of state? And so I struggled to find answers for that, but it turns out that the Prime Minister answered it himself. So I'm going to leave you with the thoughts of Mahathir on aging.
I believe that in looking after my physical self, I don't overeat, I don't grow fat, and I am active. If you follow your feelings, you're tired and all that, then you go to bed. Of course, you're not active. If you're not active, including your brain, if you don't think, you don't conceive ideas, you don't argue, you don't find solution to problem. The brain, if you don't use, it loses its capacity. You forget words, for example. I sometimes forget words, even when making speeches or answering your question. I forget the correct words. I have to make up with other words. So that's an aging process. But you don't help yourself to age faster by lying down.
I'm feeling like sunshine, like springtime, like something's in the water and I'm taking a deep dive. I'm feeling so weightless, like I'm gonna make it, and nothing in the universe can take this. I can see it clearly now, nothing gonna bring me down.